While preparing for some videos, I've used list generate extensively, and I think I finally cracked the code why the syntax is the way it is. In this video, I want to go through the two examples you see when you go to the list generate help page, which you can get inside Power Query. These two examples, starting by the symbol option, all it does is it starts at the value 10, then it keeps going down one value and it prints the actual values while looping. In the first example, you don't use the optional fourth argument, which allows you to print something that's different from the value you generate, because list generate will generate a list as expected, and in this simple example here, my iterator, my looper variable, is what gets printed. So in the first line it says an empty function which goes toward, in other words, its output is simply the value 10. And all this first line is used for is to generate the starting value. Then each loop it says keep looping as long as the current value is greater than 0. So the instant this value is equal to 0, I stop, which it will be in row 11. And then each time after printing the value, it calculates that the next value should be its current value minus 1. The trick for me to understand this function was that in this first line, why does it have to be an empty function that goes towards a value? And that's because you have to remember what each is. So if I, instead of using the syntactic sugar of the each keyword, if I instead write it out, this is a function which takes one argument, the underscore, and it goes towards whatever's on the right. Every time you see the each keyword, you can write this instead. And you could also write something else other than the underscore, which I can do like so, changing it to a, and it will do the exact same thing, because it doesn't actually matter what it is in here. And what helped me understand the function is that actually there's a bit of information hidden in this first row, because it does say it's an empty function that goes towards 10, but it's actually a bit more complicated than that, because the output isn't actually the value 10, it is that the underscore is equal to 10, because these next 2 or 3 functions, if you add the optional fourth line, these are functions that take an input, and that input is the value you get from the previous iteration. If I swap the a back to the underscore just for clarity, it's saying that the next iteration should be equal to underscore minus 1. So next underscore is equal to current underscore minus 1. And that is then fed back into here. So when it says that these two functions take an argument, that is the previous iteration's value, which is generated in this third line. And then I forgot that comments are with double slashes. Here Power Query is a bit annoying and it will delete any comments you have at the end of the line. So the trick here is to move the parentheses to the next line, and then you can write your comment. So the next underscore is equal to the current underscore minus 1. And writing this extra line here has helped me. So if I add that as a comment inline, I can say that next underscore is equal to whatever's on the right. And I need to swap these around. The trick again is that the first line here is used exactly one time to generate that initial underscore. Meaning when I'm in the first row, what is my underscore? That is the value 10. And the reason why this must be an empty function, and actually that it needs to be a function instead of simply writing 10, is that these two lines are both functions, which means that they will output a value and they can take an input. This way, the function that generates the first line, even though it's not the same function as the one that generates the next lines, both these rows are actually functions. So a function that takes no argument spitting out the first value, and a function that takes one argument which spits out the next. So you could, and I think it would be better if in this first line you didn't have to write empty function goes towards, but I can see the logic in that this is a function that goes towards the value, and this is a function that goes towards the value. And both of these lines will produce items in my list. At least that helped me understand it. Moving to the second example, which uses this optional fourth argument, and it also uses variables. The first line is still an empty function that goes towards something, but instead of printing one value, it prints a record which has two variables that we can now access. This means that my looper variable is no longer simply the underscore, it is now the underscore square bracket x square bracket, meaning that access the current iteration's value, specifically what x is equal to. But it's still the same. For ease of understanding, I still think it makes more sense to write the full function here rather than the each keyword. Because when I do this, I can specify that actually what I'm saying here is not just access x, I'm actually saying access the x, which is the current row. So adding a bit more clarity here, I can also say that my underscore is equal to the current iteration, value, meaning that when I'm actually saying the underscore here, I mean what is my current x and my current y. In this first row, my current x and y is then x equals 1 and y equal an empty list. And then I can say, okay, well, what is my condition? That is that access the current iteration, ask what is the x value? Is this value less than 10? Yes, it is. Then keep going. The trick with the optional fourth line is that I can differentiate between my calculation, which is the third line, and what I actually want to print, which is the fourth line. If I just say, okay, actually I want to print the underscore, we can see what's going on here. So it will spit out a record, which in this first row, that means x is equal to 1 and y is an empty list. Then my actual calculation for the next value is that I want the next x to be equal to do a list count, and here I'll again add the underscore. So the next iteration of x, which is the second row, that should be equal to a list count of the current value of y. And the current value of y is then this value, which is an empty list, which means that x is equal to 0, as we see. And then after calculating this new x, I can say that my next y should be equal to what the current iteration's y is. And I also want to add the newly calculated x. And what confused me so much is why should this be a normal x and not square bracket x square bracket, which we actually can't see because I have to turn that into a table first. That means that my current x is 1 because that was the one in the previous row, which means when I write square brackets around x, I'm actually referring to the current iteration of x, which means that here in the second row, well, I'm accessing the previous row, which has x equal to 1, but in this line I just calculated that x should be the list count of an empty list, which means it's 0. So it depends on what you want to do. With how I've written it now with square bracket x square bracket, in this list, I'm saying access the value of the previous row in the y column and add the previous rows as x. So this empty list and the value of 1. So here it will be the previous list and the value of 0 and so on. So with this setup, it means take the list in the row above and add the x to the left of that list. If I go back and change this square bracket to the normal x, then it means this y should be equal to the current y and the x I just calculated. Which means that in this row, I'm saying access the previous list in the row above and access the value to the left of this list. One up, grab this and add this to the left to it. And then it just keeps going. In the example provided, they don't actually print the underscore, they only print the x, which I should make sure to put in square bracket because it refers to the current value of x. And when I looked at the function, I was very confused here because why does it output 1, 0, 1? Well, I think that was confusing to look at, but it makes sense when you ask what does the function actually do. And now this is mad because it can't find the y column, so that's fine. Because in the first iteration, my x has already been determined here, because these functions both take the current iteration as its argument, which means even though I calculated a new x here, that is only relevant in the next iteration. So when I refer to square bracket x here, even though it's chronologically the next line, these two functions still take the same input argument of the current value. So x means two things, and that's why I have the square bracket here. And it's saying to actually print the current value of x. In the first iteration, I say the next x should be a list count of an empty list, which is 0. Then I say y should be equal to the empty list plus the value I just calculated in x, which means empty list plus a 0 is a list with a 0, which means my list count is now 1, and so on. And then in my last iteration, well, I calculate what the next value should be, and then after that, I print what the current value is, which is the 9. So my next iteration, x is equal to 10. But then up here in my condition, it says that, well, actually x is now equal to 10, which means it's not less than 10, which means I should terminate. And then I will print the whole list. I can try to recreate these two functions in Python, where again the simple solution starts with 10 and then it simply keeps going as long as the value is greater than 0, and the next iteration is then the current value minus 1. And the trick here then, in order to translate it into Python, is that I must have a function to generate that first value. So in the simple condition, I can say that I want a function called start, which takes no arguments, and it will simply spit out the value 10. Then I can say that my initial value is equal to the output of start, and that my current value should be equal to initial, which is very weird because why would I say that current is equal to initial and initial is equal to start? Well, that is because of how the function works, where the initial must be a function because the way you generate the next values is also a function. At least that's my interpretation. Then my output is initially an empty list, where I then add the value, the current value, to this list, and after I'm done looping, I print the whole thing. So I can say while my current is greater than 0, keep looping, and then my output list, because the function generates a list, is then I want to append whatever the current value is, and then finally I want to say current should be equal to itself minus 1. And once this is done looping, I just print the output. And then I can see it would help if I didn't write minus equals minus 1, but it should be a positive. And then I will get exactly what I expect. A list that starts at 10, because that's what I defined my initial to be, decrements by 1, and it terminates once my current is equal to 0. So that wasn't exactly exciting. In order to recreate this more complicated function in Python, I have to do some funky stuff in order to have a function that outputs a record. In Python, this would be a dictionary, but I still need to have a function that generates this value, and it has to take no arguments. So I'll start out by creating an empty dictionary, and I need to remember to give credit because I didn't know exactly how to do this, but I want to say that D should then hold an X value, which is then equal to my initial value, which was 1, should also have a Y key, which is then simply an empty list. And then I want to return D. So my starter values is simply the output of this function start. Then I have both an initial X and initial Y, which should then be equal to the starter values' value that belongs to the key of X. Likewise, initial Y should be equal to the value that belongs to the Y key in starter values. Finally, since the function outputs a list, I want a list of X, which is initially an empty list. Because in the example, we don't actually care what Y is, it's simply used in order to generate the X value, which is what I print. Again, it follows a do-while loop to keep going as long as current X is less than 10. And actually, I called that initial X, not current. And in the first iteration, it's equal to 1, so the condition is met. Then I want to append the value of X to the list. And the way it works in Power Query is that I actually calculate the value of the next X before I print my X. That's because both functions take an argument, which is the current value of X and Y. So you actually calculate the value of the next iteration before you print the current iteration. In any case, I'm going to make it simpler and say that what I'm doing is I'm actually appending the current X value to the list before I manipulate X. But chronologically, it's actually the other way around. So I want to add initial X, which is the current X, before it's been manipulated. Then I define the next X to be equal to the length of Y. And lastly, I append the initial X. Lastly, I want to take my initial Y and append the current X. And finally, I actually want to print my list X, because again, in this case, we don't actually care about Y, it's only used to generate X. And if I run that, I get the exact same output as in my Power Query function. So, yep,